Sex-linked traits actually are not that difficult because it's going to piggyback off of everything that we've already been talking about and kind of tie it all together. So when we start talking about sex-linked traits, the first thing that we want to actually look at and think about are what we talked about previously before we get to sex links. So in previous conversations, humans have how many chromosomes? Very good. You get 23 or half from mom and 23. Well, I'm going to put half in parentheses so we don't think it's 23 and a half. 23 or half. Put or so that you guys don't think that it's. If you want to put half or put 23, that's fine. I just need everyone to see that it's half from each. This means humans have how many pairs?
Two.
We don't have 2 pairs of chromosomes. For a certain gene, we have 2. How many pairs? Okay, so you have 46 altogether. Let's stop for a moment. Right now, how many shoes do you have on? 2. How many? Listen to my question.
23.
Okay, quiet. Listen to my question. How many shoes do you have on individually?
2.
2 shoes. How many pairs of shoes are you wearing, Tavarsi? 1 pair. How many chromosomes do you have altogether?
46.
46. How many pairs do you have?
23.
Wait.
Stop. This is you. Stop talking. How many shoes do you have? How many shoes do you have? You have 2 shoes. How many pairs of shoes do you have, Rosalind? 1 pair. So now, a person, same person with these shoes, has how many chromosomes?
46.
How many pairs of chromosomes does it have? 23. Does everybody see that? You look at them and you know you got 1 from mom, 1 from dad. That's 1 pair. 1 from mom, 1 from dad. That's another pair. 1 from mom, 1 from dad. That's another pair. So you have 23 pairs. That's the same thing as a set. The same thing as a pair. So you have 23 pairs. Everyone get that?
Yes, ma'am.
Okay. So when we look at our chromosomes, which is this picture here, and we'll talk about that in a moment, but I just do need to give you some vocabulary. When we look at this picture, a complete set of chromosomes, which means how much is a complete set of chromosomes? Set. All 46. So a complete set of chromosomes for humans is 46. Now for other things, it's less. A fly, I think, is like 12 or something like that. So a complete set, and don't quote me on that for flies, I'm not really sure, but I'm just giving you the example. A complete set of chromosomes in any organism is actually called a karyotype. All right? Now, one thing I want you to remember is when you develop your genes or you get your chromosomes, you said you get some from this person and some from this person. What? What are these people? Who are these people? Some from your mom and some from your dad. So this picture here is a picture of a set, a full set, which equals a what? This is a full set of chromosomes, which is called a what? Karyotype. So what we're looking at right now is a karyotype. Right here. And we're looking at all 23 pairs, which gives us a total of how many? 46. So when looking at them, let's first of all just look at the first pair. Let's say if this was the gene pair that talked about your skin, nails, all of that stuff. So we look at this set right here. One came from mom and the other one came from dad. We look here, one came from, and the other one came from, all the way through to 23. So far, so good. All right. But the difference, or what the one step further that we're going to discuss right now, is when we look at 1, 2, 3, all the way to 22, I left the color pencils at the tables for a reason. What I want you to do is take your color pencils and just going to outline these 22. So, the first 22 pairs are actually called your autosomal traits. This is all of your characteristics. Well, I wouldn't say all. Let me see. What's another word I want to say? These are your how you look, how you talk, how tall you are, how you see, how you act, your personality, all of that. So these are most of your overall characteristics. Okay? So all of these, you get one from mom, you get one from dad. That's going to be your hair color, your eye color, your skin color, the way you smile. You get one from mom, one from dad. Your height, your shape of your head, your how long your fingers are. Whether or not you had, I'm laughing because I was talking about Greek, I wasn't. It even looks down to the fact that when you look at your project, whether or not you have hair on your ring finger. Whether your thumb is a hitchhiker's thumb or not. I have a hitchhiker's thumb because my thumb bends back. Those of you who don't, your thumb won't bend back. Whether you can roll your tongue or not. Whether you have a Roman nose, which for you don't know in the project, that is a nose that kind of has a hump right here at the top portion. Whether your height is short or tall. When you look at your project, it gives you specifics about tall. 5'7" is tall for a woman. However, 5'7" is not tall for a male. What are some other things that it talks about on the project as far as the characteristics? I did the tongue rolling.
But isn't it how you choose your friends?
How you choose your friends, what your certain personality of you. The other things are widow's peak. We talked about that. How long your eyelashes are. We talked about that. My children actually have my husband's eyelashes. He has some very long eyelashes. My daughter doesn't have to wear mascara. She does, but she doesn't have to because she has long eyelashes. Dimples, freckles, your earlobes, your toe length. Your second toe, you're going to be looking at your project if you choose that one. Your hand use, whether you're right-handed or whether you're left-handed. I already talked about height, the hitchhiker's thumb or not, and even your cleft chin. And one thing I need to clarify, I told you cleft chin was the curvature. It's not. It's the butt chin. That's the cleft chin. All righty? So that's what the autosomal traits are going to look like. We still have one pair left, right? Dad. These are your color. These are your traits. So these are telling you the sex of the child, what your sex is going to be. Your sex traits or your sex chromosomes, really doesn't matter which one you put. So when you look at it, one is a particular sex, but we're going to write it out. If you have two longer, this is represented to be two female. If you have a longer chromosome and a shorter chromosome, that is XY, and that is a male. Huh? There is no YY. Going back to the question of we're making babies. Remember, talk it over with your group right now and why you think, based on what we know, why do you think the male just decides what the sex is?
Because they have sperm and whatever their sperm fertilizes.
Wrong. Try it again. That was a good try, though.
Oh, I have a question. It's about.
Okay.
like once, well, okay, I think that like the female's egg like has the sex, but once the sperm like goes into the body, it chooses which egg to fertilize.
That's a good analogy. It is incorrect, but that's good. You're thinking.
I said that because females, they just like have the egg there, so once the sperm gets inside, it's what like.
That's exactly what she. That was good though, because that's what she said. I don't wonder because it's not correct. You got to use what you know and use what you have now.
Does it have to do with like dominant recessiveness?
Kind of. Let's back up for 1 second because I'm going to help you develop this answer. Looking at the autosomal traits, how do we decide the possibility of the children having the dad's trait versus the mom's trait or having both? A Punnett square. So then therefore we take the actual trait and we do a possibility, right?
Yes.
So how can we decide the possibility of a sex?
I would say that the mom has one of them and the dad has the other one when he goes to fertilize the egg.
The mom does give one. This would always be the mom's pair. This would always be the dad's pair, correct?
Yes.
What is the difference between the two traits? Brandon. You're thinking too deep. Don't think so deep. Just looking at those two traits. Everybody, hold up your traits. Hold up both of them. Hold up both of them. Look around. What's the difference that you see?
The Y.
The Y is the difference, right?
Yeah.
Okay, so if the Y is the difference, what's the similarity?
The X.
The X. Who can give the Y?
The male.
The male. If the baby, the zygote, has the Y, it is going to be a male, a boy. So who can give the X?
The female.
Both. But, now listen, they both can give the X, right?
Yes.
But only the male can give
The Y.
the Y, and the male can also give the X. What can the female give? Only the X. So the male is the determinant factor of what the sex is going to be because the female can only bring the X to the table. The male can bring the X or the Y. So once the male brings its chromosomes to the table, it's going to add, the female always is going to bring the X. The male is going to either bring an X, which is going to result in a girl, or the male is going to bring the Y, which is going to result in a
Male.
This is why the male determines the sex of the baby.
Wow.
Is that why you're more prone to have a girl than a boy?
You can actually, it's 50-50. When we look at a Punnett square, it's going to be 50-50.
Okay.
Okay? It's always a 50-50 chance. That's why we use a coin to flip the coin to determine the chance.
Oh, wait.
Yes.
So is that okay?
I'm sorry, Chappie. Listen to the question because some of you may have the same question.
Okay, so like with twins, if it's twins on the mom's side, well, never mind, because it has never mind.
So with Jaden and Arya, right? How did that work out?
They're fraternal twins, so 2 eggs were fertilized.
All right.
All right, so now let's look back here because this goes piggybacks off of what we talked about thus far. Autosomal traits, when we're looking at it, we're going to break that down before we actually get to sex-linked traits. Autosomal traits, look at your notes or think about what we talked about. Autosomal traits are only going to talk about what type of traits? Shauna, you look confused. What's wrong? Autosomal traits are only going to talk about what type of traits? Everything except what?
Sex.
Okay, so let's add that to here. Everything, like Cat Williams said, everything except the sex.
What?
Autosomal is all of your traits except the sex. The sex traits are only the one for the sex.
So like, are some people born with like male and female parts? Yeah. So how does that work?
There's a DNA mutation. Sometimes it happens where your sex chromosomes are not what's the word I'm looking for? Are not fully developed or underdeveloped.
So if you're born with both, does your body produce both sperm and eggs?
Maybe not sperm, no, what?
No, like
Lady or male part. Yes.
Wait, so when you get the if you choose to get one of the parts removed, like how does
They have to then boost up the hormone. Good question. Let me know that you're thinking. All right, so let's go back here and look at these. Yes.
So with what she was talking about, will it still get
It all depends on what hormone is expressed. All right, so looking here at the autosomal traits. Autosomal traits are dealing with all of the traits that we've already talked about, right?
Yes.
There were two types of all of the traits we talked about. Either you're going to be this or you were going to be this. What were those two things? When the mom and dad, and you made your babies expressed the trait that was dominant or recessive. So here, you actually have autosomal dominant. So all of the traits that we've been talking about are not just dominant, but they're autosomal dominant. The other traits that we've been talking about are not just recessive, they're autosomal recessive. Because they are only dealing with the first 22 chromosomes. If you can't remember that, or you feel like you need some help, you might want to put on the side here look at first 22, not the first 48.
46.
I said 48 for the show. First 48. Look at the first 22. Any questions for that? Are we good? Okay, right? Yes.
Madison just asked me, is this like all those 22 chromosomes are for one trait, or like each set is for a different?
Remember, everything are your chromosomes. Your chromosomes are all wound up into your DNA. All of your genes.
Yeah.
So on one chromosome, this chromosome could be dealing with everything that have to do with your skin, hair, nails, the hormones that's produced and all of those things. This one may be the height, the structure, the face. Like, it's all of your genes wrapped up in all of them. Okay? Good question. Right now, what I want you to do is look to your table, actually look to your partner that's on your left. And if you don't have a partner on your left, then look to the one that's on your right. But only you should be talking to one person about what you just learned. Everyone needs to say two things, two pieces of information that you've learned. Go now. Chappie, stop drilling. I don't hear your voice, though. I should hear your voice talking.
And I know that
And then they're called
Huh? That's just the genetic makeup. Or maybe it's a choice. I don't know. I'm not the one to judge that. All right. Eyes on me. We're going to look at some, eyes on me. We're going to look at some things that characterize sex-linked traits. Again, everybody hold up your two genes. Everyone look around. The first thing that we noticed before is that everyone has what? Everyone has an X chromosome. So that's one major characteristic. Is every person has an X chromosome. And just to remind you, female is what? XX. Male is
XY.
XY. Get your minds out the gutter.
Please.
So underline, if you wrote that, the fact of the matter that you see the X's. Males only have one, the females have two. Look, everybody hold up your chromosomes again. What is something else? Look around. Look.
everybody has to look at him.
Okay, everybody does have two, but we don't even know that. We already know everybody has two. Huh?
The color.
We said that already.
The color.
Okay, I just did the color for symbolize girl and boy. Huh? Well, not capital. They're both actually capital, but when we look at them. What about the size, Kennard?
One billion.
Which one is bigger?
X.
X.
Oh, why is recessive?
The X. It's not necessarily a recessive or a dominant thing here because they both have to get one of them. And it's not the size of the chromosome that's going to represent what the sex is. It is the actual chromosome that you have. But the reason why for this, the reason why it's bigger, the X chromosome is larger. So the fact that it's larger, it's going to contain more genes. It can hold more stuff. If I tell you to put dots on that paper or fill it up, then you will be able to get more dots on the X than the Y, correct? Because it's larger. Same thing with the chromosome. The chromosomes, the amount of genes that are on the chromosome is going to depend on the size of the chromosome. So the X chromosome is larger than the Y. Yes.
So if like Jay-Z, like Blue Ivy, right, that means his X has more of his genes in it?
No. Because what's happening, you're confusing again. That last pair of chromosomes has nothing to do with your physical characteristics besides what your sex is.
Yeah.
Okay, good. All right, so having this information that you know from these two, I want you to just talk to your group for about 20 seconds. Each person talk for 20 seconds. Shauna, stop doing that face. Talk for 20 seconds and see what conclusion can you make about this. What's some conclusion? 20 seconds, go. No, you should not be talking to Erica because she's not at your group and she's not throwing you nothing. No, ma'am. No, you don't need nothing right now from her. What you need to be doing is this, please. Thank you. Appreciate it.
The Y.
All right, stop. I am going, in this basket right here, I have some traits. In a moment, you're all going to come up and grab a trait. But you can only grab the amount of traits that matches the color of what you have. So, for instance, if there's blue, how many can the male grab? One. If there's pink, how many can the male grab? One. How many can the female grab if there's blue? How many can the female grab if there's pink? Two. If you run out, just sit back down. Come on up. Quickly. Don't bump the camera, guys, please.
Can I get some traits? I want to be a trait.
Let's go. 10. Simon, let's go. Simon. 9. You got 10 seconds. Stop being lazy. 8. 7. 6. 5. 4. 3. 2. 1. Eyes up here. Now, everyone, hold up everything that belongs to you. But before you do that, your trait, hold it up next to the actual chromosome that it can belong to. So that means whatever one it's matching to. Hold them up so everybody can see. Sit down. I need both your traits up, Vernon. I need both your chromosomes up, Vernon. Both your traits. All right. So now what I've given you were traits. If you look around at everyone, we're going to conclude something from here. Where can the trait go?
Only belongs to the X.
Only to the X. Why do you think? Not based on this, it's the only one it matches up to, but based on this, why? It can contain more genes. What traits are we talking about? Say it louder. Sex-linked traits. So therefore, you can put them down and start writing. Sex-linked traits. Before we write anymore, what does linked mean? Connected or joined, like your earrings. They're linked. They're connected. Are traits linked only to what? Say it louder, everybody.
The X.
Oh, everybody.
X.
The X. Only to the X chromosome. Now, with your group, what I want you to do is answer this question. Who is more likely to have the express the sex-linked trait? So who is more likely to have or express the sex-linked trait? Question? Yes. Talk with your group right now. Come up with something.
Wait, you mean as far as the gender?
The gender.
I got the mail, so we go down.
Because you know the male carries more so
Stop. Raise your hand and tell me, who is more likely to be positive for this disease? The female, or whatever disease, or the trait, because these are going to be more likely diseases, not actual physical characteristics. Who's more likely, Brandon? Why? Okay, that's a theory. Anybody else? Okay, so let me ask you this. What if, ladies, when you got up here and you collected a trait, there was only one available for you? You would just take one, right?
Yeah.
Would you have the disease?
No.
You would be considered a what? A carrier. Gentlemen, you come up, there's one there. So let's say we have Rosalind up here with her 2 X's, and we have Brandon up here with his X and his Y, and there's only 3. Brandon grabs 2, or can he grab 2? I'm sorry, let's say I apologize. There's only 2. There's only 2 traits. Rosalind gets up here, Brandon gets up here, they both grab them at the same time, right? Does Rosalind have it?
No.
Does Brandon have it?
Yes, he has it.
He has it. The only trait that can be affected is the X. So he doesn't have a 50-50 chance like you. If he has the trait, he has the disease. If you have the trait, you can carry it. The only way you have the disease is if you have 2.
Oh.
If he has 1, he has it. So the answer here, who is more likely to express it? It's the males. Why?
Because they only have 1 trait.
They only have 1 gene because they only have 1 gene or the X chromosome that can be affected. Just so you know, females have a 50-50 chance. Either you get both or you get 1. If you get both, you have it. If you get 1, you're a carrier. If the male gets it, he got it.
So that means that strong
No.
All right? Any questions for that? Who is least likely then to express? We should say to have or express. Females. Because why?
Because we have
We
2
can be a carrier. Because we can just be a carrier.
Yep. Can either, spell either wrong. Can either, dang it.
EITHEH.
That's what I started writing, but that's not right.
That is right.
See, that looks wrong. Okay. Can either have
Miss Wiggins. Get Simon.
have the trait on 1 X and be a carrier only, or on both to have it. So they have to have it on both in order to have it. Questions about that? All right, right now I want you to go ahead and talk to your group about this information that you've learned thus far, and we're going to move on because we're going to get this nicely finished. When we come back, we can move forward.
Have the trait.
Well,
What is that? The trait.
You can carry it and it's not both your chromosomes.
If I don't have the
you know what that means.
Ahmad, I don't hear your voice.
True. We got-
All right. You should now be on the back. Who can be a carrier of the trait? We just covered this.
The female.
The female.
Why?
Why?
Could only got.
Because if they're only, if they're the only
They only get one trait.
I mean, if only one chromosome affected, then they just have it. I mean,
If only,
I mean,
well, they have, let's put, they have the possibility of only one chromosome being affected. And that one chromosome is the X. Remember, they have two X's. So this last part, we're going to finish up here. The genotypes, this is where we're going to move in, and it gets a little bit tricky, but not very, very tricky. So for the sex-linked traits, the genotypes do not just include two letters together. It's going to be a letter and a linked, or a superscript of it. So therefore, what's the genotype thus far for the sex of a female? XX. Right?
yeah.
But the way that it actually looks for a actual genotype for sex-linked traits is it's linked to it as a superscript. So let's say if we're talking about a trait and we're just talking about T, it's either going to look like this. It's going to link to the chromosome. So it's no longer, Vernon, need to pay attention. Don't write this down. It's not like dominant B, dominant B. It's no longer that. Or if it's on both of them, it's going to look like this. Or if it's on the male, what's the male's sex? XY. What's the only way the male can look?
X.
The wall.
Superscript.
X being affected.
T.
Is this possible?
No.
No, because the Y cannot have the trait. Questions?
Why is that?
It's not big enough, I just told you.
Oh.
It can't carry any of them. Any questions on this?
No.
All right, then your homework over your break is to work on your project. When we come back next Monday, we'll finish this off and we'll be moving forward. I am thankful for you.